Hello everyone, welcome to my YouTube channel, Usano-Goldie RL Marquez. In this channel, I'm going to upload a series of video presentations of lectures in differential calculus, integral calculus, and differential equations. The first video presentation of lecture that I'm going to tackle is about antiderivative of a function, which is under the basic integration in integral calculus. The five main topics in integral calculus that I have chosen to discuss are as follows: basic integration, techniques of integration, definite integrals, applications of definite integrals, and multiple integration. Let me now begin with my presentation. Basic integration 1.1, antiderivative of a function. What is integral calculus? This is the definition that I got. It is a division of calculus that deals with a measure of the total effect on the net change of varying quantities. To deal with this net change, we need to understand the notion of antiderivative or integral, its properties, and the methods of calculation. Integral calculus, also called calculus 2. Basic integration, first lecture series, antiderivative of a function. What is an antiderivative of a function? A function, which is denoted by capital F, is an antiderivative of another function denoted by small f on an interval I if the derivative of capital F of x is equal to small f of x for every x in I. To understand this antiderivative, so let us have this antidifferentiation machine. We have an input, and that is the function small f of x to be processed inside, and then the output is a function denoted by capital F of x plus c. To understand this antidifferentiation machine further, let us consider the functions capital F of x, which is equal to x cubed, and small f of x, which is equal to 3x squared. Taking the derivative of capital F, we get f prime of x, which is equal to 3x squared, and that is equal to the small f of x. Since the derivative of capital F prime of x is equal to small f of x, then we say that f is an antiderivative of small f. The function g, which is equal to x cubed minus 3, has the derivative g prime of x, which is equal to 3x squared, and that is also the small f of x. So we say that g is also an antiderivative of f. Let us have another function, capital H of x, which is equal to x cubed plus pi. It has the derivative h prime of x, which is equal to 3x squared. That is also equal to small f of x. So we say that capital H is another antiderivative of f. In fact, any function whose function value is given by x cubed plus c, where c is any constant, is an antiderivative of f. Let us generalize these observations in the following theorem. If capital F is a particular antiderivative of small f on an interval I, then every antiderivative of f on I is given by capital F of x plus c, where c is an arbitrary constant. To understand further the definition of antiderivative and the theorem that was just presented, let us have the following examples. Starting with example 1.1.1, if capital F of x is equal to 2x squared plus x, and small f of x is equal to 4x plus 1, then capital F is an antiderivative of f, since capital F of prime of x equals 4x plus